What are the parametric equations of a straight line? In a coordinate system, consider the straight line defined by a Cartesian equation of y equals to half x plus 1. The line admits a slope equals to half, so a horizontal displacement of plus 2 followed by a vertical displacement of plus 1 yields to a displacement vector of components 2, 1, which is considered to be a direction vector of the straight line as it defines its slope. Now, moving the vector aside for the moment, considering the point A on the line of coordinates 2, 2, and a variable point B on the line of coordinates x, y, the displacement vector AB is parallel to vector V and can be written as k times the vector V, where k is a real constant. Now, considering the position vectors OA and OB, according to the triangle law, OB is equals to OA plus AB. Then replacing AB by k times the vector V, we can now replace the vectors by their coordinates using column vectors. Now, what does that vector expression imply? In fact, starting from point A, if I move by one vector V, I end up at the point of coordinates 4, 3. While if I move by two vectors V, I end up at the point of coordinates 6, 4. And moving from A by the opposite of vector V, I end up at the point of coordinates 0, 1. Then the point B of coordinates x, y on the line can be found by taking x equals to 2 plus 2k and y equals to 1 plus 2k from the vector expression by setting the abscesses equal and the ordinates equal. Now, that in fact forms the coordinates of point B in terms of k. We can see that for different values of k, the point B describes the given line. Then this system of equations called parametric equations is an alternative form of equations to represent the straight line with x and y both defined as functions of the parameter k. Then given a straight line, to write a system of parametric equations, we need a point on the line and a direction vector of the line. Naming the point A of coordinates x of A and y of A, and the direction vector V of coordinates alpha and beta, you would start by writing the system of parametric equations by taking x and y equal to the coordinates of the direction vector multiplying a real parameter, t for example, then add the coordinates of the given point. And the formed system would represent the coordinates xy of any point on the line. For example, given a line with 2 points A and B of respective coordinates 1, 2, and 3, 4. To write a system of parametric equations of this straight line, I first need a direction vector. Points A and B being 2 points on the line, the displacement vector AB is a direction vector of the straight line. Finding the components of vector AB by finding the vertical and horizontal displacements between the 2 points, I end up with the components 2 and 2 for a direction vector of the line. I can start writing the system of parametric equations as x and y equal, then the components of the direction vector multiplying the real parameter t, and now I need to add the coordinates of a point on the line. In fact, I have two here. Choosing one of them, A for example, I then add 1 and 2 to the equation, which gives the parametric equations I'm looking for. But how do we convert from parametric to Cartesian equations? Going back to the previous example, since a Cartesian equation is a single equation relating x and y, then the parameter must be eliminated. I have t multiplied by 2 in both equations. To eliminate t, it must have opposite coefficients in the two equations. Then I multiply one of the equations by -1, leading to -2t in that equation. Then adding both these equations, I end up with y minus x equals to 1 as a Cartesian equation representing the straight line. But now, how do we convert from Cartesian to parametric equations? Given the Cartesian equation of a straight line y equals to 3x minus 1, the slope of the line is 3, which can be seen as 3 over 1. Then we have a horizontal displacement of plus 1 and a vertical displacement of plus 3, which leads to a direction vector v of components 1 and 3. To retrieve a point on the line, I take a random value of x, 1 for example, and find y equals to 2. Then the point of coordinates 1, 2 is a point on the line. Consequently, I can write the system of parametric equations representing the given line by multiplying the components of the direction vector by a real parameter and then add to them the coordinates of the point found on the straight line.